A basketball player releases the ball. A pilot changes course. An architect moves a wall 6 inches. 3 completely different decisions, but each one depends on something you cannot see. Position, distance, direction, angle, relationship. Change one of them, and the outcome changes. So how can we describe these invisible relationships with enough precision to predict what happens next? That is geometry. And geometry begins with a surprisingly powerful idea. The world has relationships whether we notice them or not. Start with one of the simplest ideas in geometry: a point. It has no length, no width, no height. Yet a point can tell us exactly where something is. Connect points, and we begin creating lines. Change direction, and angles appear. Combine lines and angles, and shapes emerge. Measure the relationships between them, and suddenly we can describe space mathematically. Simple ideas begin building surprisingly complex worlds. That is what makes geometry different from simply learning the names of shapes. Geometry is the mathematics of shape, position, distance, angle, size, and space. But more importantly, geometry helps us uncover the relationships between them. And those relationships existed long before we learned how to describe them. Humans observed them. We measured them. We gave them names. And eventually, we developed a mathematical language for understanding them. That language allows us to do something remarkable. We can predict. An architect can determine whether parts of a building will fit before construction begins. A game designer can create a 3-dimensional world on a flat screen. A basketball player can judge position, distance, and angle before releasing the ball. And you use geometric thinking too. When you judge whether something will fit into a space, you are thinking about dimensions. When you choose the shortest path across a room, you are thinking about distance. When you take a photograph, position, proportion, and perspective affect the image. When you use GPS, your location can be represented as a point within a much larger coordinate system. You probably do not stop and think, "Wow, I really need geometry homework right now." But you are still dealing with geometric relationships. And during this course, we are going to learn how to recognize those relationships. We will move from some of the simplest ideas in geometry to much bigger ones. We will investigate angles and shapes. We will discover when figures are truly congruent and when they are similar. We will explore transformations and measurement. We will study circles and 3-dimensional figures. But eventually, geometry asks us to do something even more powerful than calculate. Prove. Suppose someone says, "Those angles look equal." How do you know? That looks like a right triangle. How do you know? Those 2 figures look identical. How do you know? That question is at the heart of geometry, because seeing something is not the same as proving it. In geometry, we observe, we measure, we find relationships, we reason, and then we prove why something must be true. That changes the way you look at a geometric diagram. A diagram stops being just a picture. It becomes information. A point represents a location. A line can establish direction. An angle measures a turn. A shape can model an object. And the relationships between them can reveal information that was not obvious at first. So as we begin geometry, do not think of this course as memorizing a collection of shapes and formulas. Think of it as learning a new way to see. Look for the relationships. Ask what must be true. Ask what changes when something else changes. And most importantly, ask, how do you know? Because geometry is not really about memorizing shapes. It is about learning to recognize structure, relationships, and order. Those relationships were already there. Geometry gives us a language for discovering them, and once you learn that language, you begin seeing the world differently. And that is why math